I'm Nikita from Blizzard Robotics 18373, and this is speaker seminar number 2, Biomed Engineering. Angela, do you want to get started?
Yeah, sure. So, just really quickly to preface, this is about, I think, 25 to 30-minute presentation. I know on the meeting I posted with the flyer, it said it was going to be about an hour, but I think we'll probably finish before that.
That's okay. Yeah.
Um, but yeah, I can definitely save more time for questions at the end if people would like to ask more specific questions, because I'm giving a more general overview of bioengineering and biomedical engineering. So yeah, just feel free to at any time just stop me and ask questions if you want. And
Okay.
also we'll save time for questions at the end, of course.
Okay, thank you.
Let me just really quickly. Can you guys see my screen here?
Yeah, we can.
Okay, perfect. So yeah, I'm going to be giving a general overview of bioengineering and what the major entails. And this is based off my experience. I'm currently a freshman at UC Berkeley, majoring in bioengineering. I went to Archbishop Mitty High School in San Jose, California, if you guys are familiar with that. And some of my academic interests include immunology, drug delivery, and gene editing. And just some other things in general for me. I love musical theater. I love reading mystery novels, and I also love arts and crafts for whenever I'm stressed. And if you can't tell, I'm calling from my dorm room right now, so I think just to give a very brief overview of what is bioengineering, I'm not really sure. I guess I'll ask you guys real quick. You guys can type in the chat. Just interested what grade you guys are in, or you can just put I actually don't know if I can see the chat, but oh wait, I can. Yeah. If you guys want to just say what grade you're in, because I don't want to cater this to the wrong audience. Because I'm not sure how much you guys know already. Junior, perfect. So actually I would say junior year is the best time to be thinking about these things, just because it's good to be curious before your senior year, where you actually have to get into all the nitty-gritty stuff. But so for what is bioengineering, I'm just going to give you the ChatGPT answer to this. Bioengineering, also known as biomedical engineering, is a multidisciplinary field that combines principles from biology, engineering, and other sciences to develop innovative solutions for healthcare, medicine, and other life sciences. Bioengineers apply engineering principles and techniques to solve biological medical problems with the goal of improving the quality of life, advancing medical treatments, and enhancing our understanding of living systems. So as you can see, I just bolded a few key terms that I think really sums up what bioengineering is. So of course, as you all know, bioengineering combines forms of biology, engineering, and other sciences to help create solutions in the biological and medical healthcare sphere. And the only problem I have with this definition from ChatGPT is the very first phrase where it says bioengineering, also known as biomedical engineering. And the reason I find flaw with this is because the very first day at Berkeley, I walked into my Bio-E lecture, and our professor gave us a talk on why bioengineering and biomedical engineering are not the same thing. And that brings me to my next slide, which is the difference between biomedical engineering and bioengineering. So the very first thing that I'm sure y'all can see from the words is that there's no medical in bioengineering. And this may seem very nuanced and trivial, but it's honestly very important in the scope of what these majors are about. So biomedical engineering focuses a lot more on the medical industry, as opposed to bioengineering that encompasses a lot more industries. Which is why I wrote that bioengineering is more broad. There's a lot more fields to explore, and I will go over this in later slides of what fields you'll find in bioengineering, but you won't find in biomedical engineering. And also, biomedical engineering is very narrow. You primarily work with medical-related engineering problems, And I just want to put a small blurb below, since I'm sure many of you guys are juniors, sophomores, middle school, high schoolers, ninth grade, perfect. But this is more catered towards those of you guys who are thinking of doing a major in this. Both fields are great fields to major in, but you should definitely know the difference if you're interested in pursuing one or the other. And the reason I say this is because a lot of people find that they end up not liking biomedical engineering because it didn't encompass the fields, excuse me, it didn't encompass the fields that they thought it did, whereas bioengineering did encompass the fields that they did. I'm just going to give one example. A lot of you know, with the rise of gene editing, a lot of people go into biomedical engineering thinking that gene editing is something that they learn, and it turns out it's covered in 1 minute and they never touch it again. And I know this because one of my friends is currently in biomedical engineering, and she's kind of disappointed that she wasn't able to learn more about gene editing, whereas I'm currently learning a lot about gene editing. And next thing I want to talk about is what to expect if you do a bioengineering or a biomedical engineering major. And the first thing I want to say is that these are both engineering majors. It's surprising how many people don't understand that, and they go in thinking that it's more bio as opposed to engineering, but really it encompasses all. So I have to take a lot of math, a lot of physics, computer science, biology, and chemistry classes. These are all prereqs for me. So I have to take these classes before I can even start thinking about taking any bioengineering classes, because you need to have a good baseline and foundation for all these subjects before you can actually dive deep into bioengineering. And for me, I'm currently taking like a small intro to bioengineering class. They already assume you have a lot of knowledge on all these subjects. So I have a homework assignment that made us use MATLAB to create some project for our group. And a lot of the people in my group did not know MATLAB. We're also expected to know a lot of differential equations, even though we're only freshmen in college. So it's really interesting to me that professors assume that we need to know these subjects. But I suppose at the end of the day, it does make sense because bioengineering is an engineering major. It's within the College of Engineering. So this is something that a lot of people actually get surprised about because they expect more bio as compared to engineering. And the next thing is, I just want to talk a little bit about some other majors. Unfortunately, I don't have any other engineering majors here, but if anyone wants to ask a question about that later, I would love to talk more about that too. But bioengineering is not the only bio-related major. And I think it's important for other people to know about the options that there are. So I think the most popular biology major is MCB, which stands for molecular and cellular biology. And the reason this is so popular is because it's very biology focused, but it's less pure biology and more applications towards cellular or molecular biology, which encompasses a lot of what people like learning in AP Bio if you've ever taken AP Bio before. Also, people who are pre-med really like taking MCB because you have all the prerequisites there for you. You don't need to take any extra classes. Of course, a lot of people who are in bioengineering are also pre-med, but they do have to take some extra classes because we're not actually required to take any biology classes. So they have to take extra classes for that. Another major is IB, also known as integrative biology. This is more in relation to the environment. A lot of people who are interested in environmental science or environmental engineering like taking IB because there's a more environmental aspect to it. And the last one is pure biology, which is, in my opinion, not the best biology major to take because it's so broad. And in my opinion, if you're going to do a major in college, you should try to narrow down as much as you can. So instead of just majoring in mathematics or just majoring in biology, I recommend taking an aspect of that and try to find something that you're interested in that narrows down your subject, because sorry about that, I don't know if you can hear that, but having a general major, it's a lot harder for you in the future if you want to narrow down what job or what internships you want to do. So I highly recommend being more narrow with what your major is. And lastly, I just want to say that a lot of bioengineering is application based. which kind of makes sense if you're thinking in the realm of engineering. Because engineering is very much problem solving and applications, whereas a lot of the biology majors I listed here is more memorization. So if you prefer memorization, I highly recommend taking one of the biology majors I listed here. If not, if you like more application, if you like doing math, physics, CS, bio, or chemistry, I highly recommend bioengineering or biomedical engineering. And now I'm just going to go a little bit into the fields of bioengineering. So there are four main concentrations, and this, just to preface, this is based on what I understand from Berkeley's curriculum. This may not be the same for every college, but for me, this is how I understand bioengineering split into. So the first concentration is biomedical devices, which, as you guys may know, is part of biomedical engineering as well as bioengineering. So this is where I want to split up a little bit about what is biomedical versus what is bio-E. So biomedical devices, as you guys may think, this is where you use a lot of electrical engineering knowledge and mechanical engineering knowledge to create devices. I think this is one of the most popular concentrations at Berkeley, at least, because it encompasses a lot of CS and bio, which is an interest that a lot of people have. The next one is computational biology. So this is more focused on the data analysis and computer science side of biology. This is also a major by itself. So if you go on a lot of college websites and you just search up computational biology major, it'll show up as its own major. But here at Berkeley, it's part of the concentration for bioengineering. But if you guys are also interested more in the CS side of biology, I recommend checking out computational biology. Just like a little tip too, anything that has the word computational in it in front of the major has to do with CS. And then another one is biomedical imaging, which is also a bit of a subsection of biomedical devices, but I know a lot of my biomedical imaging professors have disagreed with that, so I'm not going to go into that argument with them, but this also uses aspects of electrical engineering, computer science, and in my opinion, this is the most flexible concentration because you can do so much with a lot of the other engineering majors in your college. I know one of my friends currently is doing biomedical imaging, and she's working in a nuclear engineering lab, which I find really, really intriguing. And lastly, there's synthetic biology. So this synthetic biology works a lot more closely in the lab. If you are someone who likes working hands-on with research, highly recommend synthetic biology. There's different names for this. There's also cell and tissue engineering is what they call it, but at Berkeley, at least, it's called synthetic biology. And I just want to give some other subsections of bioengineering that are not part of biomedical engineering. So the first one is drug delivery. And this has actually been a very recent interest of mine. I have never, if you've taken AP Bio, you know that you don't learn a lot of this in class, which I think is a shame because it's so hard for students to know what they want to do in college if they've never ever heard of half of these things before. But drug delivery is part of the subsection of cell and tissue engineering and synthetic biology. You also have biomaterials. Berkeley actually has a joint major with bioengineering and material science and engineering. And a lot of people who do this joint major end up going into biomaterials or working for biotech companies that work specifically with making the ingredients of whatever product they have. And then another one is immunoengineering, which is a very rising field because especially with new research in cancer oncology, immunoengineering combines immunology and engineering together. And I'm actually currently working in a lab that has to do with immunoengineering. So if any of you guys are interested in learning more about that, please ask me any questions later. Another subsection, this one's not necessarily a subsection, but I added it because a lot of people are actually really interested in this, and it's modeling and simulation. So you're using a lot of coding, CAD, 3D modeling, prototyping, and combining that with creating devices. And the next one, gene editing, or also known as genetic engineering. This is very big in bioengineering. I have a lot of friends who are interested in that, and especially at Berkeley because Jennifer Doudna, who is the 2020 Nobel Prize winner in chemistry for her work in CRISPR and gene editing, she's a professor here at Berkeley. So this is a very hot topic, especially in bioengineering. And then the last one is regenerative medicine, which has to do with cell and tissue engineering. This one you're working a lot in lab. There's I think a lot of professors in bio-E actually work with regenerative medicine. I'm not sure why, but it's definitely a very popular concentration, especially among professors, which I find pretty interesting. And the next slide, I just want to go a little over. I know a lot of you guys are in high school and not even high school, but I think it's important to just know like what types of companies out there that work specifically with bioengineering and what could a possible future look like for you guys if you do end up majoring in bioengineering or sorry, or biomedical engineering. So I think based on your interest, I'm going through concentrations again, but biomedical devices, a lot of companies such as J&J, Medtronic, and Abbott, I think are some of the most popular biotech companies currently. For computational biology, there's AstraZeneca, there's Illumina, there's Bayer. I think a lot of these, I think a lot of these have overlap. For example, Johnson Johnson, if you guys may know, they worked on the mRNA vaccine for COVID, and that really surprised me because they're mainly a biomedical device company, but they do branch out. A lot of these companies branch out into other aspects of bioengineering, which is why I really appreciate this majors because it's so flexible. And especially with a lot of what's changing in society and the technology boosts, especially in science, a lot of these companies have expanded a lot of what they do to be more flexible for people. And also why currently I have a lot of senior friends who are looking for internships, and a lot of them focused mainly around the Bay Area, since the Bay Area is such a big hub for bioengineering. I think it's a really great experience because if you want to do an internship at any of these companies, and I'll list a lot more later, but if you want to do an internship at any of these companies, they're very flexible on putting you where your interests lie. And I think that's a great way to get some hands-on application and knowledge of what it's like to work in industry. And going on, biomedical engineering, Philips, GE Healthcare, Siemens Healthcare are all very popular with imaging. And lastly, synthetic biology, Agilent Technologies, Amyris, and Merck Laboratories all work with some sort of cell tissue or synthetic biology. And I guess just to preface, don't think you guys can see this, but I'll use the laser pointer. Biomedical devices, imaging, and computational biology. These three usually are away from the lab. So if you choose to work more with CS, I would say either devices or biology, computational biology or imaging are all great resources to that. And just a preface, I personally do not like CS, but I think it's a very important skill to learn for really any major, especially STEM major, because it's such a versatile tool to just have in your skill set. And I honestly wasn't expecting to have to do any CS classes in bioengineering, but I have to take quite a few. And it's also very important for just learning general basics for engineering, because if you're in bioengineering, you need to be well-rounded in all aspects of STEM majors in some subjects. And moving on, so some other options if I'm including a lot of like academia as well as industry. A lot of people go into med school after undergrad, and personally, I have quite a few friends who are currently pre-med and they're working on med school, trying to get into med school. And I think I'm not pre-med, so if any of you guys are interested in pre-med, I will try my best to answer your questions, but I can't say that I know exactly what answers to give because I'm not very familiar with application process or what pre-med is in general. But a lot of people go into healthcare, end up becoming doctors, PAs, surgeons, etc. Another option is going to graduate school or PhD, which is basically further education. In my opinion, for my future at least, I'm hoping to go into PhD right after my undergrad because I really love research and I want to continue doing research. And yes, that is an option. Actually, you can skip graduate school and go straight to PhD if you want. And personally, in my opinion, for STEM majors, it might actually be better than graduate school, because graduate school is really just more classes and work. But if you're someone who's interested in research, PhD might be a better option because you get hands-on research in labs and you actually get to rotate between labs to pick what you want to do in the future. So I think this having further education is honestly a great idea. But if you're more dead set on industry, that is also totally fine. The next option I put here is biologist or engineer. And what I mean by this is that if you're a bioengineer or a biomedical engineer, you're well-rounded in biology and in engineering because you have to take so many prereqs that requires you to have a very grand understanding of a lot of subjects. You can really fit into whatever you need. If you end up finding you don't like bioengineering, you can easily switch to biology, or you can easily switch to another engineering major because most engineering majors have to take the same amount of prereqs because it's engineering and you need to be well-rounded in a lot of subjects. The next one is genetics, as I've talked about before. Some very famous companies are Thermo Fisher, Caribou Biosciences, or Neogen. And as I mentioned before, a lot of these companies branched out a lot. Thermo Fisher actually, I believe, has an optical sphere, which means that they work with eye care as well. They also work with genetics, and they also work a lot with research, which I find interesting. The other one is pharmaceuticals. And I think this won't come as too much of a surprise, but a lot of pharmaceutical companies need bioengineers because it's such a big part of their company. For example, I'm interested in drug delivery and possibly might work for a pharmaceutical company in the future. But some examples would be Bristol Myers Squibb, Roche, and Pfizer. And lastly, if you're interested in business and bioengineering, I highly recommend looking into any consulting firms, either for internships or for a future job. And consulting basically means that these are companies that give advice. So a lot of consulting firms, such as Bain and Co., Deloitte, or Accenture, they work with medical or the healthcare system, provide advice to a lot of medical related companies. And next, I think I'll just briefly go over this. I don't know if you guys will be too interested in my experience so far with Berkeley and bioengineering. But this right here, this is a picture of me and some of my friends with the current bioengineering head of Berkeley, who is Professor Messersmith. He does some incredible research with biomaterials and nanotechnology, and all around great professor. This is me at Meta. I believe Meta's headquarters, or not headquarters, one of Meta's companies is about 30 minutes away from Berkeley. So my friends and I just took a trip one day down there and we got to talk with a lot of Berkeley alumni, which was really fun. And I got to get some advice from them on interviews and coding in general. This is another one of my professors, Professor Leitman, who works with biomedical devices and imaging, specifically glucose monitoring and insulin delivery. And honestly, all around really cool. Honestly, all the Berkeley bioengineering professors are incredibly cool. Like it's insane what their research is, and to me, it's like it's baffling that people can think about doing research related to these things. This is the engineering head. So she's the head of the entire engineering department. She's also an EECS teacher. And for those of you who don't know, EECS is a combination of electrical engineering and computer science. And it's one of the most popular engineering majors at Berkeley. And this is just at an event, and I love talking to her. She's so nice. And this, if you guys don't know, is the 2020 Nobel Prize winner in chemistry, which I think I mentioned a little bit before. She worked with CRISPR and gene editing, and she was a guest lecturer in one of my classes. And I was so lucky to be able to talk to her in such a small class setting because we all got to ask questions, take pictures. She signed, I had the biography of her book and I got her to sign that, which was really, really fun. And this is a little more labs or research if you guys are interested in that. I'm currently working in a lab, so I took some pictures of how crowded it is in that lab. This down here is just my mentor was doing an SDS page, which is basically electrophoresis with gel electrophoresis. And I'm sure if you guys have taken AP Bio, you've probably done gel electrophoresis before. This works specifically with proteins, and they're using electrophoresis to separate proteins to be able to look more closely at them. This is a fume hood, but they're using it as storage because we have no room in the lab. Personally, I was not expecting labs to be so small, but it's very cramped in there actually. This, oh my God, my professor, I just want to put this here. My professor put a meme. When you see a claim that a common drugs or vitamin kills cancer cells in a petri dish, keep in mind so does a handgun. Basically means don't believe everything pharmaceutical companies tell you, especially not advertisements. And this right here was a microscopy class that I took that I really, really loved. I got to work with extremely high-end microscopes, and I was honestly kind of scared of touching them, but this is a Hu7 liver cell, and it's incredible because in high school, you can't really see much of cells when you're using them, but this, you can see like the nucleus, the mitochondria, lysosomes, you can see the smooth ER, some peroxisomes around there, and this is all in like a petri dish. So really, this really baffled me. I thought it was really, really cool. And lastly, I have to show you guys that I do have a social life even at Berkeley. But this is just a picture of the Golden Gate Bridge from the Campanile, which is the highest tower at Berkeley. This is a night market where a lot of Asian student organizations just give you free food, which is awesome. This is my friend group, which I'm so lucky to have been able to meet. And I think just to say for everyone here, if you're worried about making friends in college, don't, because it's honestly so easy to find a good community no matter what college you decide to attend to. And I'm honestly really lucky to have been able to meet all these people my very first day at Berkeley. So yeah, it was at Silent Disco. That's why the guy behind has like red earphones. I went to a volleyball game, and this is just Berkeley at night here. I also went to my first ever baseball game, which was really fun. And oh yeah, this is my professor's dog, which he brings to class every single day. And it's really the only reason most people even go to class. But yeah. And lastly, I just want to give some tips and advice. I don't think there's any middle schoolers here, so I'm just gonna skip this part. But to preface, just some advice I would give you if you are a middle schooler, try to take STEM classes you're interested in, join or start your own club, take summer classes if you're free, and you can even talk to your teachers about anything college related if you're interested. And as a high schooler, I highly recommend doing summer programs. Personally, I did all three of the ones I listed here. I did SRA and RMP, which are both UC Santa Barbara based summer programs. I also did Cosmos, which is a more math related summer program. So SRA and RMP are both intro to research, sort of. So they both work with research for high schoolers. So they make it so that it's easier for you to learn what research is like and what it's like to write a research paper. And I think that's important if you want to do bioengineering, because research is such a big part of bio, or engineering in general. I'm taking a intro to bioengineering course, and my project, or final, technically, it's a final project, is writing a research paper. So if you don't know how to do that, it's really, really hard. So I think it's a great way to get just some interest in, do you really like research? And if not, maybe bioengineering isn't for you. Another thing is take summer classes. Stanford has summer classes, Berkeley has summer classes, San Diego, UCSD has summer classes, UCSB has summer classes, U Chicago has summer classes. Almost all colleges you can think of probably have summer classes. Does this mean you'll get into the school if you take a summer class there? Not necessarily, but I think just taking it at any college near you that's affordable and cost effective, I highly recommend you do that, because it gives you a good understanding of what college classes are like. And let me tell you, going from high school to college is it's so different, especially with classes. Like you have to self-learn a lot, and you can't rely on teachers to give you answers all the time. half the time they don't even know what they're talking about because they're going so fast, and then they have to go back because people cannot follow. But yeah, I think it's important to just know what college is like, and also take some classes that you're interested in, like I said before. But really, if you want to get more interested in this major, bioengineering, there's so many subsections, and I think it's important to look at each one. And lastly, I think I mentioned this already, familiarizes yourself with research papers, and any other bioengineering topics that you're interested in. I highly recommend doing this, especially if you're about to apply for college, just because I think it's important to know the different programs that each major can give you and what you will be learning for that major. Because you're going to be in that major for 4 years, or most people switch out of the majors because when they first applied, they didn't really understand how the major worked. So I think it's really important that, of course, switching majors is fine, but I think it's important to stick with a major for as long as you can because you get more exposed to it as you go along. So it's really good if you're able to get a major down the first try. But then again, a lot of people switch majors, and that's totally fine because they end up realizing that it's really not what they want to do. And I currently have a friend who's thinking of switching out of bioengineering because she didn't realize she had to take so much math and physics, which she absolutely hates. But yeah. And just some last tips. Remember to have fun in high school. Life is not only about college. You should take a lot of the extracurriculars that you find fun or interesting. Personally, I did musical theater for 4 years in high school. That has nothing to do with bioengineering, but I still put it on my college applications because it's something that really shows creativity and originality. Also, if you don't know what you want to major in yet, that's totally fine. A lot of people end up only figuring that out in college. College is really a time for exploration. Like, I'm still exploring a lot of the different parts of bioengineering and a lot of the other majors in case that I really want to switch. Currently, I think I'm sticking with bioengineering for 4 years. I don't think I'm gonna switch anytime soon. But really, I think it's better to explore in college because you're within that atmosphere of students who are also trying to figure out college alongside with you. And also, lastly, just continue doing things that you're passionate about, whether that's academic or not. Personally, for me in high school, I joined the chess club, I joined the rock climbing club, I joined the esports club, I even hosted an esports tournament. But I think, especially if you're in your last few years of high school, highly recommend doing some fun clubs, really just to chill. Also, there's nothing wrong with putting fun clubs on college apps. I think it's actually better if you put something fun in there as opposed to straight up academics. And this is coming from someone who was salutatorian of her high school, but yeah, I highly recommend having more variety, especially because it shows you're someone who's not just fully obsessed with academics. But yeah, that's all I have right now. I think I actually went over a little bit. Um, but yeah, go ahead and ask me anything you want. You can type it in the chat if you don't want to just talk out loud. This can be about classes, college, research, majors, jobs, internships. Even if you're in high school, you want to ask about APs or school, I'm your person. I'm probably taken most, I hope I've taken most of the APs you guys are currently taking. But yeah.
I just have a quick question.
Yeah.
So, if you're interested in, if I'm interested in biology,
Mhm.
do you know like what I can do to like through volunteering that'll like relate to those fields?
Yeah. I think for volunteering specifically or just any activities.
Uh, both, I guess.
For volunteering, I know a lot of people do this, but they volunteer at local hospitals or veteran organizations. Personally, for me, I volunteered at a veteran hospital for I think 4 years or 4 or 5 years. I can't really remember. I think that was, I want to be honest, that's probably the most volunteering related thing I did to biology. For other activities, I recommend, I think I talked, let me go back. Um, I recommend doing programs related to biology, especially over the summer, because most people are free over the summer. It's really hard to do it during school because you guys have a lot of APs, I know, and it's not easy to juggle that. But over the summer, I took a lot of research courses research programs such as SRA, RMP, or Cosmos. Cosmos not really bio oriented, so I wouldn't recommend doing Cosmos. But SRA and RMP, I highly recommend just search up that really quickly and just look through that. If that's not interesting to you, that's fine. You can also take summer courses. I took a U Chicago summer course on biochemistry and biophysics because I was interested in those topics. Turned out I actually don't like them, but I still put it on my college application because it's technically part of community college classes. I think what else you can do is if you have any clubs at school related to bio, highly recommend you join them. We had a biology club, and every semester they did the USABO tests. If you guys don't know, it's the USA Bio Olympiad test. If you get past the first round, that's already incredible because it's not easy to pass that test. I had a friend who got to the finals for that, which is insane in my opinion. I could only get past the first round, but that also looks pretty good. It's a really good activity to do in my opinion because you get to learn a lot from that, and also you get to apply it when you're taking the test. But yeah, sorry, I don't know if that's a good answer to that.
Yeah, that's fine.
Let me see. What is the student to teacher ratio like at Berkeley? So I'm gonna talk specifically for bioengineering. I'm not really sure for other majors. I will say this though, UC Berkeley is a public school, so we are very understaffed and underfunded. I have 3 professors who are both bioengineering professors and EECS professors, so they're teaching 2 different majors. I think the student to teacher ratio is probably like 1 to 5. I could be wrong. You should definitely like look that up. But I have my current lecture for Bio E10 is I believe it's a lecture hall of 300 people and there's 2 professors teaching it. But in college, a lot of people don't go to class. So it's really easy to talk with professors if you're looking to talk with professors to talk during lecture because there's no one goes. It went from a 300-person lecture hall to 20 people going to lecture. It's actually kind of insane. Also, if you want to talk with professors, highly recommend you go to office hours. Their office hours will be posted on whatever website you look on. If you just search up your college, go to bioengineering, look at faculty, it'll show their office hours there. And you can just drop by, even though you don't know them. I've dropped by like I think 5 professors who have no idea who I am, but I had a lovely talk with all of them about research and classes and college in general. So I think there are many ways you can connect with professors, but you need to take the initiative for that because they're not going to go to you. You have to go to them. Another one. Hi, Angela. This was an awesome presentation. Thank you so much. You mentioned the head of bioengineering doing research with biomaterials and nanotechnology. Are there a lot of similarities between nanotech, nanoengineering, and bioengineering? Is there a good amount of biology involved with bioengineering? Okay, I honestly apologize. I totally forgot to put nanotechnology into one of the subsections. Nanotech is so big at Berkeley. When I was in high school, I had never heard of nanotech or anything related to nanotechnology before. But coming to college, there was so much about nanotechnology, like even not just bioengineering professors, but MCB professors, IB professors, bio professors, all work with nanotechnology. I had no idea it was such a big thing, but if you're interested in that research, there are so many professors that work with it. I think similarities between nanotech and nanoengineering, there's a lot because you need to have a good bio background. So I'll just preface this, but I'm working in a lab that's doing immunoengineering, and I'm working with lipid nanoparticles, which is a part of nanotechnology. I will say it's definitely more on the bio side as opposed to bioengineering, but there's definitely research that applies nanotechnology to engineering. Because for us, we're doing drug delivery, which relates a lot to engineering and pharmaceuticals. But yeah. And is there a good amount of biology involved in bioengineering? Yes. I know I emphasize the engineering side of it too much, but there's also a lot of bio that goes into bioengineering, just a little less than you might think. It's not completely biology. There's also a lot of engineering that goes into it. I think they actually kind of expect you to know basic biology going into the major. Because for me, the very first few lectures, they dive deep into things that you should know for AP Bio. Uh, and also, we're not required to take any bio classes, which is very interesting to me. At Berkeley, there's an intro class called Bio 1A and Bio 1B, which are like the two intro classes. But surprisingly, we're not required to take that. You immediately jump into Introduction to Bioengineering. And I think that's probably because bioengineering is an engineering major and they have their own curriculum for that. But there's definitely a lot of bio. It's just they expect you to know it already. Were there any specific classes that you took in high school that piqued your interest in biomedical engineering? I think the obvious answer for that would be AP Bio, AP Chemistry. I think a little bit of math, simply because the reason I chose bioengineering and not just a regular biology major is because I was good at math and I didn't want to throw that away, which sounds kind of stupid in hindsight, but I think I wanted to be able to encompass a lot of the skills I had in high school and not lose that. I mean, I didn't particularly hate math, but it was something that I knew I was good at and I wanted to keep doing if I could. So I decided on an engineering major and I looked around and I saw bioengineering and biomedical engineering and I was like, that's a perfect blend of the two things that I love. So I ended up deciding to do bioengineering. And I think specific classes, I took summer classes on biochemistry and biophysics. And I also did a research program, which, oh yeah, it's on screen right now. SRA and RMP, and for both of these research programs, I wrote a biology related research paper, and then related that to engineering as well. So I think it wasn't specific classes, but more like in general, everything. Also, I've always been interested in bio. I think because I have a lot of medical conditions that really force me to look at life through a biology perspective because I worked a lot with immunology. I have like allergy doctors visits daily, so for me, I think bio's just been so prevalent in my life that I knew I was going to do something bio related in college.
I just have one more question.
Yeah, sure.
So right now I'm a sophomore in high school.
Mhm.
So I'm not really interested in that much chemistry classes, but the next year I decided to take I'm probably gonna take AP Bio and
Mhm.
probably later physics.
Mhm.
So does it really require like chemistry to be that big of a part, or do you have any like suggestions for that?
So we have to take general chemistry and organic chemistry, which are the two worst chemistry classes. I will say though, I think it's fine if you don't like every subject in engineering. I don't like coding and I don't like physics, but I still have to take those classes because it's required. Um, I think taking AP Bio is a good start, especially because it's bioengineering, and taking physics is also a very good start. Highly recommend actually for all of you guys to take the three big STEM subjects, uh, which is bio, chem, physics, and then math. I'm not going to list just because you need 4 years of math in high school, anyways. Um, I think it's fine that you don't like chemistry because, like, a lot of people in bioengineering don't like all the subjects that they have to take. But I think it's good to know chemistry because you're going to have to take it, no, even if you like it or not, because it's just a prereq, it's required. And the reason is because they want you to be able to be well-rounded in all aspects of STEM if you're doing bioengineering.
So how much years of chemistry would you recommend, or like which classes?
Um, if your school just has regular chemistry or chemistry honors,
Yeah,
you
I'm
don't
taking.
have to take, huh?
Yeah,
Sorry?
I'm right now. I'm taking honors chemistry.
Oh yeah, that's perfect. I only took honors chemistry. I've never taken AP chemistry before. But having honors chemistry was good because I remember some stuff that really helped me. So just like to equalize this what was it? Chem 1A, which is what you have to take for Berkeley, is equivalent to AP chemistry. And technically chemistry honors also goes over AP chemistry stuff, just less in detail. So I think you should be fine if you take chemistry honors. Honestly, if you don't like chem, I don't recommend you push yourself to take an AP chemistry class because you will suffer. But yeah, I think it's good that you're taking chemistry honors right now because that's a good introduction.
Okay, thanks.
I don't know if anyone has any more questions, but if not, I'm perfectly fine with ending here. I know it's a little early and I did go over. I didn't think I was gonna talk for 35 minutes, but yeah, it was really nice talking to you guys and I really enjoyed it. Thank you so much, Nikita, for inviting me today. If any of you guys have just last minute questions, actually, let me put my email here in case you guys have any last minute questions that you think of afterwards that you would like to email me about. Again, I highly recommend if you're interested in bioengineering or biomedical engineering. I know I specifically talked about bioengineering. It's because I'm not as familiar with biomedical since I'm doing bioengineering. I recommend researching about it. Google is your best friend. Honestly, ChatGPT is your friend as well. So you can look stuff up. And I'm sure there's a lot of videos online about it too. But yeah, thank you guys so much.
Thank you so much, Angela. We really learned a lot from the presentation.
Thank you.
Thank you.
Thank you.